We're going to be graphing linear inequalities today. All right. That means less than, greater than, less than equal to, greater than equal to. An inequality is any mathematical sentence that contains the symbols greater than, less than equal to, or greater than equal to. In a graph, if it is less than or greater than, it will be graphed with a dashed line to indicate that the line itself is not part of the solution, but it's only a boundary line. So these lines that you draw are going to be boundary lines to the solution. And if it's dashed, again, it's not part of the solution. That's because you can't have something equal to itself. It's got to be less than or greater than. Here, if you come down here, we've got less than equal to, greater than equal to. And it will be graphed as a solid line to indicate that the line itself is part of the solution and is also a boundary line. Okay. Now, when graphing, we graph this like we always do. Graph normally. Okay, so we're going to graph 2x minus 3. We're going to start at negative 3 on the y-axis. We're going to go up 2 to the right 1, up 2 to the right 1 for the slope. Now, this has a less than sign. So because it's less than, it is a dashed line. Now, you need to determine, that's the second step, whether it's solid or dashed. We've already said it's a dashed line. Then we need to shade one of the sides. Now, how we do this is we pick a point. Now, honestly, less than makes sense that it would be below the line, but sometimes these lines get so steep that you sometimes get confused, and this method always works. So if you plug in, and the easiest one to plug in always is 0, 0. The only time you wouldn't plug in 0, 0 is when the line itself is going through the point 0, 0, then you would need to pick another point. But you can always pick any point you want to. So anyway, we're going to plug 0, 0 in, and as you see, we're just going into the regular equation. 0 for y, 0 for x. Is 0 less than? That's a mistake. Glad I saw it. And it's supposed to say negative 3. But the point still holds. 0 is not less than negative 3. 2 times 0 is 0, minus 3 is negative 3. And 0 is not less than negative 3. So your point 0, 0 is on the false side. It didn't make our statement true. So therefore we know we need to shade the other side. Every point on this side of that line will make this equation or inequality true. Every point on this side. So keep that in mind. Every point on this side is a solution. The line itself is not. Okay. Y is greater than negative 2/3 x plus 1. Again, we graph the line. Start at 1, go down 2 to the right 3, down 2 to the right 3, and it is another dashed line. Then you plug your 0 in. Is 0 greater than 1? No. So you shade this side. You shade above. This one has to be put in slope-intercept form. So you move the 4x over, and I changed it to greater than equal to. All right, so y is greater than or equal to negative 4x plus 3. Graph the line. I'm not going to go over how to graph that line. You should know by now. Okay? Now, we're going to graph that line, and we're going to plug in 0, 0 again. Now, everything I've done so far, when I plug in 0, 0, 0, 0, has not been a solution. Be careful thinking that it won't ever be one. This is just the way that my examples turned out. So, is 0 greater than or equal to negative 13? Yes. Yes, it is. That just ticks me off. So it should be shaded on this side. Oh, I used another point. I used the 0.40. Okay, having a moment. So when you use the 0.40, I think I used another point just to get you to see. So when you use the 0.40, 0 is greater than or equal to negative 4 times 4, which is negative 16, and it is true. And that point is right here. So therefore you shade. I wanted you to see me do another one, and I just didn't realize and didn't look at it carefully and see that. So anyway, I hope I didn't confuse you. All right, that's good.